Okay, I'm sure you were wondering in the last video, what if the du is not so conveniently located in the integrand? What do we do then? So let me show you what we do in that situation. So in this example here, I have 6x and then x squared plus 5 to the 4th power dx. I can see the inner function, so I know that U-substitution is required. In this case, U, the inner function, is x squared plus 5. And du then is 2x dx. So what I'm noticing now is if I replace x squared plus 5, I've got u to the 4th. And what's left over is this 6x dx. But what we have for du is 2x dx. So all we need to do is a slight modification to the du to make these two things match. In other words, I want this 6x dx to be some form of du, because I need a du here. I need the derivative of the inner function, or at least some modification of that. So what I notice is that this 2x dx is 1/3 of 6x, or 6x is 3 times that. So if I just multiply 3 on both sides of my du equation, I get 6x dx. So now I can make my substitution. I've got u to the 4th. 6x dx is the same thing as 3 times du. Now everything is in terms of u. Let's do just a little bit more simplifying. There's two ways you could do this. We could write this as 3 times u to the 4th du and find the antiderivative that way. Or you could just pull the 3 out and write this as u to the 4th du and find the antiderivative that way. To be honest with you, I like to keep the 3 in there because I don't want people to forget about the fact that there's a 3 there. So I'm just going to keep my 3 in there, and I'll show you what we're going to do with it. So 3 is the coefficient. So I'm going to add 1 to the exponent. So that's now u to the 5th. And then I'm going to divide the coefficient by that exponent. So this just becomes 3/5. Just like that. So keeping the 3 inside of the integral is no big deal. I'm going to replace u with x squared plus 5. And there's the antiderivative. Not too bad. Okay, I'm going to give you another one to try. Oh, that's not a very good combination, but I'll use a different color next time. I'm going to give you one to try now. So this is the first one. Try this, please. Let's see. All right, give that a shot. See if you can modify your du to match what we have in the integrand. Okay, I hope you tried it. Let's get to work here. So the inner function, that's why we're using U-substitution, is because there is an inner function, is 3x cubed minus 6. du is 9x squared dx. Okay, so if I make my substitution over here, I have u to the 9th power, and then I have 2x squared dx. So I'm going to have to modify my du in order to make these two values the same. So I'm going to multiply both sides of this du by 2/9. 2/9 du, and if I multiply 9 times 2/9, I end up with 2x squared dx. Okay, now I can make my substitution. I can replace the 2x squared dx with 2/9 du. I'm going to bring the 2/9 out in front. Now I'm going to work backward from the product, or the power rule. I'm going to add 1 to the exponent, that's u to the 10th. And I'm going to divide by 10. So this will be 2 over 90. Plus some constant. 2 over 90 reduces to 1/45. I'm going to replace u with 3x cubed minus 6. to the 10th plus some constant. I'm going to choose a different highlight color this time. Okay, let me give you one more of these and then we're going to change, or we're going to take a slightly different approach. So let me give you one more example. Let's see. Actually, I'm going to do two examples. I have to get some trig in there, of course. So let's see. Let's do this one. Sorry, I want to change this. Okay, give that a shot. See what you can do. Okay, welcome back. I hope you tried it. We're going to let u equal the inner function. In this case, the inner function is x squared plus 10/3 x. du then is 2x plus 10/3 dx. What I notice is that 6x plus 10 is 3 times as large as 2x plus 10/3 dx. So I'm going to multiply both sides of this by 3. So that'll make this 6x. 10/3 times 3 is 10. Now I can make my direct substitution. This becomes u to the 1/3. And 6x plus 10 dx becomes 3 du. All right. So now we've got 3u to the 1/3 du. I'm going to work backward from the power rule. Add 1 to 1/3, that's 4/3. Dividing by 4/3 is the same thing as multiplying by 3/4. So this becomes 9/4 plus a constant. So my final answer then is this. Okay, I'm going to show you another, oh, I said I was going to give you trig, didn't I? Let me give you trig. How about this one? This is not super intuitive. It's not as easy as you think. So I really would like you to pause this and try a couple different approaches at this before you come back and watch the rest. Okay, welcome back. Now the first thing people do, this is one of the strangest problems. The first thing people do is they say u equals 2x, and that makes absolute sense because 2x is an inner function. And then du is 2 dx. So I would do 1/2 du is dx. The only problem with that is that now we end up with sine of u, cosine of u, and then 1/2 du. The problem is I still don't know the antiderivative of sine times cosine. So letting u equal 2x in this situation did not make this problem any more simple. There is not an antiderivative that we're aware of, not a simple one, for sine times cosine. I can't think of anything where if we find the derivative, we get sine times cosine. So letting u equal 2x was actually not the correct approach. Instead, if I let u equal the sine of 2x, watch what happens when we do that. So if I find du, I'm going to need to use the chain rule to find the derivative of sine 2x. So the derivative of sine is cosine without changing the 2x, and then multiply by 2, the derivative of the inner function. So that's du, is 2 cosine 2x. Now if we do some replacement here, sine of 2x, that's u, And then we have the cosine of 2x dx left over. I'm really close. If I just multiply both of this by 1/2, then I get the exact match that I need for my du. All right, so I've got u. This becomes 1/2 du. If I rewrite again, 1/2 u du. Antiderivative of 1/2 u, if I add 1 to the exponent, that's u squared. 1/2 divided by 2 is 1/4. And here's the antiderivative if I make the replacement. That one was tricky. It kind of defies some of the rules that we've been following all along. I did see an inner function, but that inner function of 2x didn't seem to help me much. But there was a product there, which I can't integrate, so U-substitution helped in that case too. It's kind of a strange problem, but a good one. Okay, finally, the last type of problem we're going to work with is this. Let's see, number 5. Let's see. Okay, let's see what we can do here. I see an inner function. The inner function is 3x plus 6. du is 3 dx. I don't have a 3 in my dx, so I'm going to multiply by 1/3. So 1/3 du is equal to dx. If I make my replacements, I've got u to the 12th. dx becomes 1/3 du. And I have an issue. I still have that x left over. Remember we talked about earlier the properties of integrals. You can only pull a constant out in front. We can't pull that x out in front. So we need to deal with it somehow. We have an extra x in this problem. I want everything to be written in terms of u because that makes this problem much more simple to solve. It's just power rule then. So what I'm going to try to do is write x as a function of u. And I'm going to do that using my original u value here. So if I have u is equal to 3x plus 6, I can isolate x and get u by itself. So if I subtract 6 first of all, 3x equals u minus 6, and then divide by 3, x is 1/3 u minus 2. So now I can make that substitution as well. Let's do this here. I've got 1/3 u to the 12th. X now becomes 1/3 u minus 2, and I still have my du. Now, everything is written in terms of u. That's supposed to make this problem a lot easier to solve. But my issue right now is I have a product. We can't find the antiderivative of something that is multiplied. So we're going to distribute this to make this look more like a polynomial. That way we can work backward from the power rule. So I'm going to distribute 1/3 u 12th in. That makes this 1/9 u to the 13th. And then 1/3 u to the 12th minus times -2 is -2/3 u to the 12th. Even though this looks scary, now it's just power rule. I'm going to work backward from each of these separately. So I'll start with 1/9 u to the 13th. First, I'll add 1 to that exponent, so that's u to the 14th. Then I need to divide 1/9 by 14. That's 1 over 9 times 14, so that will be 1 over 9, 112, I believe. Okay, now we'll do the same thing on this one. This is u to the 13th. I add 1 to that. If I divide by 13, that's 2 over 3 times 13. I definitely know this one. If I'm wrong on 112, I'm sorry, but I think I'm right. Okay, so the last thing we need to do is replace u with 3x plus 6, and we're back to our original, or to the original function that gave us the derivative up above. Not quite as intuitive. This one was a little bit more tricky. but using U-substitution helped us get there. Okay, let me give you one of these to try, and I think that's going to be enough for now, and then you'll have more practice in your homework. Okay, let's do one more. Let me see, how about this? 3x times, let's do 3x squared times the square root of 2x squared minus 4 dx. All right, go give it a shot. Oh, forget it. Never mind, this one's going to be too hard. Sorry, let me give you a different one. This one's going to be a lot better. Let's do this one instead. Try that one instead. That's going to be a lot easier. Okay, go. All right, welcome back. I hope you did this. I hope you tried it, because these are important that you work them out on your own. I see the inner function, that is u is equal to 4x minus 8. du is 4 dx. So I'm going to make those substitutions first. First of all, I see that I have a 3 dx. So I'm going to make that adjustment right now. I'm going to multiply this by both sides by 3/4. So 3/4 du will give me 3 dx. Okay, I'm going to make that substitution first. I still have this x out in front. I haven't replaced that with anything yet. 4x minus 8, the square root of that becomes u to the 1/2. And 3 dx becomes 3/4 du. All right, now I have this extra x, so I'm going to take my u value, the u equals 4x minus 8, and I'm going to isolate x. So I've got 4x equals u plus 8, divide by 4, x equals 1/4 u plus 2. All right, I'll make my substitution. This is 1/4 u plus 2 times u to the 1/2 times 3/4 du. I'm going to do some distributing. I'm going to multiply u to the 1/2 in here, and I'm going to multiply 3/4 in here and here to make this all just one polynomial looking function. So first of all, 1/4 times 3/4, that's 3/16. U times u to the 1/2 is u to the 3/2. 2 times 3/4 is 3/2. And then u to the 1/2. Okay, now that I've got it in the form of a polynomial, I can just work backward from the power rule. So I'll add 1 to the exponent. This is u to the 5/2. I'm going to do a little bit of work off to the side. If I do 3/16 divided by 5/2, that's the same thing as 3/16 times 2/5. So this becomes 3/40. Okay, similarly here, I'm going to add 1 to the exponent, so now that's 3/2. 3/2 divided by 3/2 is just 1. That's nice. Okay, last but not least, I'm going to replace u with what we originally had, which was 4x minus 8 to the 5/2 plus 4x minus 8 to the 3/2 plus some constant. Okay, there's a lot going on. It's really important that you keep things organized and you keep track of all of your substitutions. Make sure everything in that integrand is replaced with some form of u. That makes this problem much more simple to solve. All right, go try this out on your homework.